Okay, so we need to solve the simultaneous equations here. Okay, different type of equations here. We've got x squared plus y squared equals 10. Okay, so this time we've got a y squared involved as well. Okay, and then equation 2, then x plus y equals 4. Now, if we focus on equation 2, right, that's one we can work with quite easily, and you should notice there that actually represents a line, okay, because if you think about it, with equation 2 here, we could rearrange it. We could say y is equal to 4 minus x, yeah? We could take that x over the other side, and you get minus x, and that kind of looks more like your mx plus c, yeah, that you used to, y equals mx plus c. So we can rearrange equation 2 into a format which is more useful for us, because if you notice now, I've got an expression for y, yeah, or I've got an equation for y, you know, in terms of this here, in terms of a number and an x, yeah. So I can say y is equal to 4 minus x. Now, I haven't got y equals here, okay, in equation 1, just like we had in the earlier questions. I haven't got y equals, but what I can do, okay, when I solve simultaneously is I can substitute in, okay. So for instance, I can substitute in an expression for y from what I've got here in equation 3. So when I say now solving simultaneously, okay, obviously the y values will be the same for both equations, okay, both equations here. And the x values will be the same, okay, when we get our results out. But, you know, if I use equation 3 here, which is a rearrangement of equation 2, I can simply sub this expression for y into the first equation here. So I'll say, look, substitute 3 into 1, okay? And what you'll have is, you've got x squared here, but instead of saying y squared now, I can replace y with my expression here, okay? So I've got 4 minus x, and notice I put it in a bracket because I need to do y squared. So I'll write it like that, and then of course equals to 10. So I haven't done anything wrong, okay? I haven't done anything wrong. I'm solving the equation simultaneously, and instead of saying x squared plus y squared equals 10, I'm now saying x squared plus 4 minus x all squared equals 10. I'm writing y in terms of what I've got here from equation 2. So now what I do is I'd expand this here, right, and simplify it. So when you expand this, don't forget you've got a double bracket here, yeah, because it's bracket squared. So you can end up doing FOIL. So you've got x squared. I'm going to do FOIL here. First is 16, outers is minus 4x, inners minus 4x, and lasts minus x times minus x is plus x squared equals to 10. Simplify it, right? So put the x squareds together. I got 2x squared. Minus 4x is minus 8x. And I've got 16 here, but then if I bring that 10 over, that becomes minus 10. So 16 minus 10 is going to be plus 6 equals 0. So then I've got a quadratic which I'm sort of familiar with, and I can look about factorising it. But just before I factorise it, I want you to notice, if you notice here, there's a common factor of 2, okay? So we could divide this quadratic by 2, just to make it a bit simpler. And if I halve everything, I get x squared minus 4x plus 3, okay? That's a lot easier to deal with. And I have a double bracket, x in both. So I just need to think then of a pair of numbers that multiply to give 3 and add up to give minus 4, okay? So 3 and 1 clearly work, yeah? And actually I need to make them both minus, don't I? Because if I make them both minus, that will add up to give minus 4 and multiply to give 3. So I've got that there, equals to 0. So 2 brackets equal to 0, times together, that means one of them's got to be 0. So the first bracket's got to be 0, or the second bracket's got to be 0. So x will equal 3, or x will equal 1. And all I've got to do then is sub it into equation 3 to work out y. So in this case then, when x is 3, y will equal 4 minus x, so 4 minus 3, which is 1. And when x equals 1, y will equal 4 minus 1, which is 3. So I've got 3, 1 and 1, 3 as my points of intersection. Okay, we're done.